Sorry, we kind of got cut off there. I lose track of my time. But anyway, so what I was talking about here is the idea of production of heat, production of sound, and production of light, all of which are energy changes. It actually could be any kind of temperature change. So it could be heat given off, but it could actually be energy gained, which causes its temperature to change and get colder. But in any case, what I was talking about here with the production of heat, the one thing that kind of catches students is that oftentimes they think that what we're talking about here is heating something up, like using a hot plate, using the microwave, or using the stove or oven. But this is a heat that is happening from within the substances. I think probably the best example of this would be like the instant heat packs. Maybe some of you have used those when you've gone to a football game, or you've gone out hunting, or maybe riding snowmobiles. These little packages that you shake the contents of, and they actually get warm, and you're able to then put them in your mittens or put them in your boots and keep your extremities warm. That's the type of production of heat that we're talking about. The reverse, of course, would be when it can get cold on its own. And if you've ever used an instant ice pack, you've seen that as well. You pop the little bubble that's in the middle, which causes a mixture of chemicals. Those chemicals start to react together and produce a new compound. But in the process, the energy is being absorbed from the surroundings, and that causes the temperature to go down, and it feels cold to us. The last example here of a sign that we might be able to see that a chemical change is happening is a formation of a precipitate. That sounds like a really fancy word. We're not talking about precipitation like the rain coming down in the sky. Instead, this is when you mix together liquids and a solid actually forms. So that's something that I'll have to show you, I guess. It's hard to describe. It's important to note that chemical changes cannot be reversed by a physical change. So if a chemical change has occurred, we won't be able to undo that using a filter or even evaporation and heating it up is not going to actually cause it to change because those are physical processes. And if a chemical change has occurred, new bonds have formed, and we have a whole new substance, the only way to undo that, if it can be undone at all, is to undo it using a chemical process. So keep in mind then that we could separate a mixture using physical processes, but compounds that have been formed through a chemical reaction can only be broken down by chemical change. So what are some ways that we could separate a mixture? Well, you did the virtual lab the other day, and that's what that was all about. So you were able to identify the properties of the materials that were in the mixture and then choose methods for separating it based on those properties. So, for example, you can separate seawater, which has salt in it, into its parts by heating it, because when the water evaporates, the salt remains. And that was one of the steps in your process in the virtual lab. Another example is using a filter. You were able to separate the sand from the salt water in that virtual lab because the salt dissolved in the water and the sand did not, leaving bigger particles that would not go through the filter. So identifying the properties of the matter that you're working with in the mixture are key to figuring out how to separate it and what processes you can use to do that separation. So knowing that iron actually was magnetic allowed you to use a magnet to separate the iron filings out of the mixture in that virtual lab. It's sometimes even simpler than that. I don't know if you're like me, but if I have a bag of gummy worms, and we've got red ones and orange ones and yellow ones and all of these different colors, my favorite are actually the clear ones. And so I can separate out the ones that I like the best based on their appearance, based on the fact that there are clear ones in the combination of all of these different colors in the mixture. So we can use any of the physical properties to help us to work out how we might be able to separate a mixture. There are other more complicated methods for separating mixtures, and usually that's because the mixtures themselves are more complicated. Using distillation is a method for separating liquids when you have mixtures who have different boiling points in them. So, for example, if you have ever watched the show Moonshiners, or if you have ever seen in a movie somebody using a still, that is shorthand for distillery. If you've gone out to an ethanol plant and done a tour, that's a giant distillation. The reason that the method works to separate the alcohol from the water that it is mixed with is because water boils at a higher temperature than alcohol does. So if we put a mixture of alcohol and water, overheat, and we raise the temperature to about 76 degrees Celsius, the alcohol will actually start to boil away. Well, we don't want to keep the water. We actually want to collect that alcohol as it boils away. So if you've ever seen the copper tubing that is in a still, or if you've ever seen the condensing tubes at an ethanol plant, what that is all about is cooling down the alcohol that has turned into a gas so that it recondenses back into a liquid and can be caught in another container. So distillation is a process that works because the mixture has parts that have different boiling points. We can also do differences in density to help us separate a mixture, and a centrifuge can help us with that. A centrifuge is essentially a quite simple machine that just spins things really, really fast. So if we put a mixture into a test tube and put that test tube in the centrifuge, when it spins really, really fast, if there are differences in density, the more dense material will be drawn to the bottom of the test tube, and the less dense material will rise to the top. So if you have seen on the counter, maybe in your doctor's office, they sometimes use a centrifuge when they are doing blood tests, and they will separate the platelets and the red blood cells and the white blood cells from the plasma using a centrifuge. But if it is not a mixture, it is a chemical compound, then we can't separate it using those kind of methods, and we need to have other methods for doing it. Sometimes it is as simple as heating it up, because heat can cause a chemical change. Mercury 2 oxide, when it is heated, will actually start to decompose, and it will break apart into mercury and oxygen. If we pass a current, an electric current, through melted table salt, we can get the sodium and the chloride ions to separate and get sodium and chlorine back from that. We can also use electrolysis, which is the method of using the electric current, to separate hydrogen and oxygen in water. But all of those are chemical changes, and that is the only way to separate the parts that have combined chemically.